This is Mrs. Ziegler, and I'm going to go through drawing free body diagrams. So in class, you should have received this as your notes. So these are just more extension notes for drawing free body diagrams. So here it talks about the representation of what a FBD is, which is a free body diagram, and then it talks about the different types. So what I'm going to do is I'm going to go through and we are going to use these different examples to draw free body diagrams. I will do 4 of them that are from this list, and I would like you to attempt to do number 2 and number 5 in your notebook, and then for me to check so that you know that you have done this correctly. So first one, so here is an example. So if I give you a picture of this, in this case, when we're giving you examples, we're going to actually just give you a statement, a scenario, where this is just a picture. Okay, so here is our scenario. We have a book that is at rest on top of a table. So remember, when you're drawing free body diagrams, we start with a box. You can use a box. In the directions, it does say use a dot, whichever you would like, but essentially you just want to represent your object. You do not have to draw a rendition of a book on a table. You can just draw like you see here. So everything on Earth always has at least this one force that is acting on it. So remember, it's the non-contact force of gravity. So automatically, you're always going to put on every single object that you're drawing forces, you will always put gravity going down. And this is F of G. This is the gravity force. Now, when it's resting on a surface, meaning a table, a chair, on the floor, you will always have the perpendicular force going straight up, opposite of gravity, which will be your normal or your support force. In this case, it'd be F of N. So for this particular scenario, a book at rest, meaning it's not moving, you have 2 equal and opposite forces, gravity and normal force. This is for every object that is on a surface. So a book on a table, a chair on the floor, just anything in which it is at rest, it will look like this. If this object was moving at a constant speed, it still will look like this. The next scenario will be number 4, which we have a rightward force that is applied to a book in order to move it across the desk with a rightward acceleration. What this means is the book is moving faster than constant speed. It was probably moving, or it was at rest, but then a force was applied by a person to push the to push the book across the desk. So again, you have your object. You have your downward gravity force, okay, then which is F of G, and then you have your upward normal force or your support force, F of N, and then because it's applied force being pushed to the right, the arrow, in this case, the arrow should be, in this case, it looks like it's a pulling force because it's on the other side. And this is F of A because it's applied. But all that you want to make sure is that it's a rightward force because it is going to the right. And then, because it is moving, you have friction force, which is the opposite of the applied force, and that's F of F. Now, you can see here that the applied force is larger than the friction force, so therefore it's showing that there is motion. And that's what it means by rightward acceleration. All right, the next one is number 7. So a skier is sliding down a hill of a slope of 22 degrees. So now here I show a slope. This may be 22 degrees, but this is just for showing your free body diagram. Again, we have our object on the surface. It has a downward force going straight down as gravity, F of G. And then it has an upward force, which is perpendicular to its surface, which is the F of N. This is showing a skier sliding down a slope of an angle of 22 degrees. And then the last one is a football that is moving upwards after it's been kicked by a punter. Okay, so again, after it's kicked and it's going upward, okay, that means that the object, again, here's the football, all the forces that are acting on this object at this point after it's been kicked by the punter is just gravity, F of G, going down. So again, I would like you to do number 2 and number 5 in your notebook and have me check it to make sure that you do know how to write free body diagrams.